Hey guys, we're doing question 17 from section 3.4. So, we'll jump right into this. What is this question asking for? Well, this is the first time in this section it's getting to the product rule, as you can tell because there's a multiplication here, and the chain rule together. So as in question 15, it wants you to see the hidden bracket in the exponent function. If you were to put this into a math program like Maple or MATLAB, you'd have to write it like this. There'd be like an exp function, an open bracket, and then your minus 3x inside it. And it would output this. So basically you just have to imagine there's hidden brackets anytime you see an exp function like this. So, and if you see brackets, it's probably a giant red flag chain rule is going to be necessary. I want you guys to get in your head, if you see brackets and there's anything involving your x, probably a chain rule problem. Alright, so let's take derivatives. First, we're going to apply the product rule, and then we're going to apply the chain rule. The product rule is basically derivative of the first part, with the second part left alone, plus derivative of the second part with the first part left alone. Sorry, I hope I said that right. Anyways, what's written on the screen. And so I also put brackets around the x2 just to specify we're only taking the derivative of just the first term in the first term, and in the second term we're taking derivative of the second part. So the derivative of the first half, it's really easy. The derivative of x squared is just 2x. You guys probably know that by now. And so I just wrote it again, and now I'm going to try to take the derivative of the second part. So for the second half we have to use the chain rule. We know our inside function is negative 3x, and our outside function is just an exponential function. But first let's just remember our basic derivative rule. The derivative of e to the x is just e to the x. Right. So yeah, just remember though that there's actually a hidden chain rule here that we never really write for convenience, as we discussed in question 15. So more or less, we're taking the derivative of e to the x, which is giving us e to the x back again, but we're also deriving what's on the inside of e to the x. In this case, the derivative of x though, it's just 1, so we never write this. But we're basically going to follow the exact same process to our second half. So I'm writing x squared in front, because we can't just drop that off, and then I'm taking the derivative of this e to the negative 3x. So the first step is you just write it again without doing anything, and then you try to take the derivative of what's on the inside. And so the derivative of what's on the inside is negative 3x. When you derive negative 3x, you just get a negative 3. And now I basically just move that negative 3 in front in the next step because it makes it look nice. And you end up with negative 3x squared e to negative 3x. And so for the most part, you're doing a very basic, easy derivative. And yeah, then you just combine the second half and the first half together, and we just get this expression here. And yeah, that's all you had to do to solve this problem. Hopefully you guys found this helpful. Okay, hey guys, there should be a playlist button there if you want to look at more videos. If there's a specific question you need help with, even if it's not a textbook, just let me know in the comments. Have a good day, guys, and good luck. Oh, I also recommend after you watch about 5 of these videos, go back to the first one and try to solve it on your own.